Hey there everybody, today's lesson is about probability. First we have to become familiar with some vocabulary, so please pause the video and take a moment to read through this first page. Example 1. We want to find the sample space for each experiment. Experiment A, one coin is tossed. If only one coin is tossed, the sample space is either heads or tails. There are only two outcomes in this sample space. For part B, if two coins are tossed, it can either land heads, 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 tails, tails, heads, or tails, tails. And what's confusing sometimes about this sample space is that these two outcomes appear exactly the same, but we have to count heads, tails, and tails, heads as two individual outcomes in order to keep each event equally likely. We're just as likely to get heads, heads as we are to get heads, tails, or tails, heads, or tails, tails. So in example B, there are 4 outcomes in the sample space. The probability of an event is defined this way. P of E, it's kind of like a function read that way, P of E, the probability of event E equals the number of outcomes of the event divided by the number of outcomes in the sample space. So it's essentially just, you can think about it as a fraction, the numerator of the fraction having to do with the specific event that you're considering, and the denominator is always going to be the total number of possible outcomes. One thing to note in probability, that a probability is always going to be between 0 and 1. 0 would be an event that's impossible, that can never happen, and 1 is a certain event. It would have a probability of 100%. Now that we have this definition, let's take a look at a few examples. So here's our first 5 examples. If you'd like to, at this point, pause the video and try these on your own, and then you can start it back up and you can listen to my explanations. Example 1, two coins are tossed. What is the probability that one will land heads up and the other will land tails up? Well, we just looked at the total sample space of 2 coins being tossed. So we can think about the denominator being 4. There's 4 possible outcomes. And what is the probability that one lands heads up and the other will land tails up? Well, we saw that there were 2 outcomes in that case, and we should always simplify the fraction, so the probability is a half. Example 2, a card is drawn from a standard deck of playing cards. What is the probability that the card is a heart? Well, there are 13 total hearts, and there are 52 cards in a deck. So the event here is the fact that a card is a heart, and the sample space is the entire deck, which is 52 cards. We can simplify and get 1/4. Example 3, a 6-sided die is tossed twice. What is the probability that the total of the 2 tosses is 5? Well, let's think about this particular event. For this particular event, we could have a 1 and a 4, a 4 and a 1, a 2 and a 3 and a 2. So there are 4 outcomes in the event. If we think about the sample space, that is all of the total outcomes, or all of the possible outcomes. That would be a lot to list. It would be a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, all the way up until we get to 6 and a 6. So the easier way to think about the sample space is to go back to the fundamental counting principle that we covered in the last section. So we can think about 2 events happening. The first event is one of the dice is tossed, and there are 6 ways that you can roll one die, times 6 ways that we can roll the second die. So the total sample space, there are 36 possible outcomes. So 4 out of 36 is going to be the probability that the total of the 2 tosses is 5. We can simplify that fraction and end up getting 1/9. Example 4. If a graduate is selected at random, what is the probability that the person is female? So this is the probability that the person is a female out of the total number of graduates. An easy way to do that, to figure out the number of females, would be taking the total amount, subtract the number of males, and we get 672 out of the total 1354. You can pop that into your calculator to simplify and hit math frac. We get 336 out of 677. Example 5 is kind of an interesting question. I'm going to show my work over here. In this case, let's start with the denominator. Let's think about the sample space, or the total number of possible outcomes. Well, the total number of possible outcomes in this case is the number of ways that we can construct a test that has 10 questions out of a bank of 20 study problems. So we can use a combination here. There's some combination of the 20 total questions, choose 10. And then the numerator is the number of ways that this student can correctly answer all of them. Well, if the student only knows how to correctly solve 17 of them, the total number that we have to choose from is 17 in the numerator. And out of those 17 that the student knows how to solve, 10 of them are put on the test. So it's a combination of 17, choose 10. Use your calculator. You can hit math probability to simplify this, and you would get 2 over 19. Mutually exclusive events. Two events, A and B, from the same sample space are mutually exclusive if they have no outcomes in common. And this symbol here, it looks like a U. You can think of it as or. What is the probability of A or B? Well, if they're mutually exclusive events, it's really simple and it's intuitive as well. The probability of A plus the probability of B is the probability of A or B. Here's an easy example to think about. We have a bag of jelly beans. 5 are red, 6 are green, and 8 are yellow. You're going to pick one, and we're assuming that we mix these together, so the outcomes of pulling any of these jelly beans is equally likely. So what is the probability that the jelly bean is red or yellow? So let's think about that. The probability that it's red or yellow is just the probability that the jelly bean is red plus the probability that the jelly bean is yellow. Well, we can take the probability that it's red. We know that there are 5 red out of the total number of jelly beans in the bag, which if you add all those together, you get 19. Plus the probability that it's yellow. We have 8 yellow, again, out of the total 19, and then we can add those 5 plus 8, we get 13 out of 19. Now, I know this is a simple example and you probably could have gotten straight to the answer without showing all of that work, but when the problems get more complicated, it's really helpful to have a formula to think about. Here's where it gets a little more confusing. If they are not mutually exclusive events, if they're not mutually exclusive, that means that they share some outcomes. So in that case, we have this formula, and this is one I recommend you memorize because it's going to be used quite frequently. The probability of A or B, again, remember that this symbol means or, is the probability of A plus the probability of B minus the probability of A and B. So this upside down facing you can think of as and. And let's think about this example here. We want to know the probability of pulling a heart or a face card from a standard deck. This is an example of not mutually exclusive events because a card can be both a heart and a face card at the same time. So this diagram is really helpful for us to think about because if we just added the probability that a card is a heart plus the probability that the card is a face card, we would be counting the Jack of Hearts, the Queen of Hearts, and the King of Hearts twice. So we can't just add probability of A plus probability of B. We have to account for this overlap. And the way that we account for that overlap is by subtracting it out. So let's go ahead and solve this now. Probability that a card pulled at random is a heart or a face card equals the probability that it's a heart plus the probability that it's a face card minus the probability that it is both a heart and a face card. Probability that a card is a heart is 13 out of 52. Probability that a card is a face card, there are 12 total face cards in a deck out of 52. And then how many cards are both hearts and face cards? Well, there are 3 of them. There are 3 cards that are hearts and face cards out of 52. And then we can add 13 plus 12, subtract 3, and we get 22 out of 52, which we can simplify and get 11 out of 26. When events are independent, it means that when one event happens, it does not affect the probability of the other event. So we can read this formula as the probability of A and B, this means and, equals the probability of A times the probability of B. Let's go through each of these examples. Again, at this point, if you want to try some on your own, I encourage you to pause the video, try these 4 on your own, and then see if our answers match up. Example 9, there are 11 numbers that are less than 12 out of 30 times 11 out of 30, and we get 121 out of 900. Example 10, probability of landing on the head side of a coin and rolling a 3 on the die. Well, there's a 1 in 2 chance that we get a head, and there is a 1 in 6 chance that we roll a 3, so we get 1 out of 12 for the probability. Example 11, it's important to note that we are replacing it. So just keep that in mind because if you weren't replacing it, it would change the probability. But for this one, we've got 5 out of 16 times 6 out of 16, 15 out of 128. Example 12, a card is randomly selected, the card is noted and not placed back in the deck. This procedure is repeated 2 more times, that all 3 are face cards. Well, the probability that the first is a face card is 12 out of 52. Because it's not replaced, we would then have 11 left out of 51. And then that's not replaced. Sorry, this should be another times sign, times 10 out of 50. And then you can multiply all those together and get 11 out of 1105 for your final answer. The complement of an event is simply 1 minus the probability of the event. This should be really intuitive. So something that is not in A, it's denoted A prime. So the probability of A prime or the probability of not A is equal to 1 minus the probability of A. Let's think about this example. The probability that a card is not a club would be 1 minus the probability that it is a club. The probability that a card is a club, there are 13 clubs out of 52. So we can subtract and simplify and get 3/4. That's it for our lesson on probability. Thanks for watching.